welcome back to Geometry. We're going to talk about Chapter 2, which is the logic part. Remember I told you that geometry is made out of algebra, it's made out of drawing, and it's made out of lawyering. So this is the lawyer part. Now, this is weird, so just kind of accept it right now. But what we're going to talk about today, the truth doesn't matter. I know, how can the truth not matter in math? Well, it's because this is the lawyer part of it, right? So what we're going to learn is certain ways to state things that are called conditional statements. And you're going to find that it doesn't really necessarily make true statements, but it is a certain way you have to say it. So we're going to learn these 4 ways to say something called if-then statements. So our first example of an if-then statement is this. If it is noon in Georgia, then it is 9 a.m. in California. That's a true statement, and it has an if and a then to it. And so while we're doing all of this, is we are going to write proofs in math, and those are true. But learning the logic part of it about this, sort of like a haiku poem. In haiku poetry, you have to have your syllables just so. Doesn't matter what you say, but as long as you say it the right way, it's a haiku poem. Same thing with these statements. It doesn't really matter what we're saying, just if we're doing it the right way, then we're saying the statements right. But then we're going to take what we learned from this and apply it to proofs. And proofs are true. They're mathematical ways of proving things that are true in math. All of this will make more sense later. And so I talked about that. I can erase it. All right. So this, what we're going to do first is we're going to practice making things if-then statements. So I have something right here that's a statement. It says 2 points are collinear if they lie on the same line. Now, we want to make that an if-then statement, so we could say if 2 points are collinear, then they lay on the same line. Or we can say if 2 points lay on the same line, then they are collinear. Notice there was more than one right answer. In geometry, when you get to the proofs, there's more than one way to write a correct proof. Now, there's lots of ways to be wrong, and everything you write isn't right, but there's more than one way to write it and it be right. It's like an essay in English. There's a lot of ways to write a correct essay about your dog, but there's also a lot of incorrect ways to write an essay about your dog. There's not just one answer to this. I know some of y'all have just decided you don't like geometry when I said that. There can be more than one answer. All right, so let's try another one. We're going to make it if-then. All sharks have a boneless skeleton. We could say, if a fish has a boneless skeleton, then it is a shark. Now, is that true? I don't know. Are there other things that aren't sharks that have boneless skeletons? See how the truth doesn't really matter? Or we could say, if a fish is a shark, then it has a boneless skeleton. Both of those are ways to turn that statement into an if-then statement. Here's another one. A number divisible by 9 is also divisible by 3. We could say it like this. If a number is divisible by 9, then it is also divisible by 3. We turned all of those into if-then statements. Now, there are 4 different ways of writing these statements. They are called conditional, inverse, converse, and get a load of this, contrapositive. That sounds fancy, doesn't it? I always love it when you get to do fancy math. This seems a little fancy. So, the conditional statement is just your regular if-then statement. If A, then B. So it would be if it is noon in Georgia, then it is 9 a.m. in California. The A is it being noon in Georgia. The B is it being 9 a.m. in California. The if is also called the hypothesis and then the conclusion. Later in your book, they use P instead of A and Q instead of B, which is so hard for me as a dyslexic. I remember being in 3rd grade and looking around at my other 3rd graders, and or in 4th graders, it was 3rd and 4th grade, thinking, how do they all seem to think that P, Q, B, and D are different letters? Because to me, they're all the same letter. And somehow these other kids can tell a difference in these letters, and I cannot. So, I like the A and B better than the P and Q, but, you know, as I've gotten older, I've learned to take my time and do things so that I'm not quite as dyslexic. I'm still dyslexic, but I've learned how to overcome it. We shall overcome. All right, so the next one is called the inverse. It's the same as the conditional, but it's not, okay? So for this one it would be, if it's not noon in Georgia, then it's not 9 a.m. in California, okay? Converse is you flip them. You say the B first and the A second. So you would say, if it is 9 a.m. in California, then it is noon in Georgia. And the contrapositive, you flip them and make them negative. So it would be, if it's not 9 a.m. in California, then it's not noon in Georgia. Woo, you did it. This is it. So you're going to have a bunch of these on the test where you have to do the 4 statements. And truth has nothing to do with it. It's just, can you write it? And I'll show you that in a second. Okay, so now, counterexample. If they do care about if something's true or not, and you have a conditional statement, if you find a counterexample, you have to throw the whole thing out. Sometimes they don't care about truth, sometimes they do. So here's one example. If x squared equals 16, then x equals 4. Well, that sounds true, but what about, couldn't x be equal to negative 4? So we found a counterexample, so that means that our if-then statement is not true without some modification. We would have to rewrite it. Okay, so let's try doing our 4 statements with this one. If you see lightning, then you hear thunder. So that's the original, the conditional. Now let's do the inverse. If you don't, now first of all, is the very first statement true? No, it's not. Sometimes you have one without the other, but we'll go ahead and pretend. Okay, if you don't see lightning, then you don't hear thunder. That's the inverse, also not true. Converse. If you hear thunder, then you see lightning. You just switch them. Once again, not true. Contrapositive. If you don't hear thunder, then you don't see lightning. Once again, not necessarily true. All right, let's do another one. If 2 segments are congruent, that sign means congruent, meaning they're the same length, then they have the same length. Okay, so that's the original. Let's do the inverse. If 2 segments are not congruent, then they don't have the same length. Now let's do the converse. If 2 segments have the same length, then they are congruent. Now let's do contrapositive. If 2 segments don't have the same length, then 2 segments are not congruent. Let's try this one. This is the original. If the measure of angle A is 30 degrees, then A is acute. Okay, so that's original. Now we're going to do inverse. If the measure of angle A is not 30 degrees, then angle A is not acute. That's not true. It could be 31 and still be acute. But that's just how you would write the inverse. Now we're going to do the converse. If angle A is acute, then the measure of angle A is 30 degrees. Also, not necessarily true. Now we'll do the contrapositive. If the measure of angle A is, if angle A is not acute, then the measure of angle A is not 30 degrees. So see, it's not hard. It's like haiku poetry. You don't even have to think about it, you just do it. Here's another one that also has some not true. This is the original. If there is snow on the ground, then flowers are not in bloom. So notice this is positive and that's negative. When you change it to inverse, if it's positive, you make it negative. If it's negative, you make it positive. So for this one, the inverse would be, if there is not snow on the ground, then flowers are in bloom. Okay? The converse would be, if flowers are not in bloom, then there is snow on the ground. And the contrapositive would be, if flowers are in bloom, then there is not snow on the ground. We flipped it and changed the positive negative. All right? Y'all did okay. I didn't hear anybody screaming and running from the room. All right, so you're going to read this carefully through. Then on page 73, we have a lot of postulates. One's like between 2 points. There is exactly one line. A line is made out of at least 2 points. When 2 lines cross, they do at 1 point. 3 non-collinear points are on a plane. If a line's on a plane, then if 2 points are on a line, if a line is on a plane, then 2 points on that line are in the plane. And the intersection of 2 planes is 1 line. So read over those postulates, make sure you understand them, and we will be using those later in proofs. So, hope you have fun with this and enjoy it. Not too hard, a little confusing, but not too hard. Math is fun.